Good evening, everyone, and welcome to the Computer History Museum. I'm John Holler, the CEO, and I'm just delighted to welcome all of you here tonight for this very, very special evening honoring the life and work and career of really a remarkable engineer, Jim Williams. This, unfortunately, has been a year of losses in the computer industry. It started with Ken Olsen, the founder of Digital Equipment Corporation and someone who was very instrumental in the launch and roots of this museum. Jean Bartik, who is a fellow of this museum and who was one of the 6 women, all women, who programmed the ENIAC computer working with Eckert and Mauchly in the 1940s. Paul Barron, the pioneer of packet switching, one of the legends in internetworking computing. Of course, Steve Jobs, and just this week, Dennis Ritchie, the originator of the C programming language and one of the key minds behind Unix programming. And, of course, Jim Williams and his good friend, Bob Pease. But remembering these losses this year is not really the point of this evening. This evening is really more about the celebration of Jim Williams, his amazing mind, the influence that he had on so many engineers around the valley, the pioneering work that he did in analog computing, much of it unnoticed and unsung outside the industry itself. That really is the point of this evening. Now, how did the Computer History Museum come to intersect with the life and career of Jim Williams? Well, it's really a very happy story, I think, and it's one for us as a museum that is really a kind of landmark effort. When Jim had this untimely passing over the summer, word began to filter back to us about this absolutely amazing workbench and this office that he inhabited at Linear Technology. And the museum has really never tried to capitalize immediately on what I have now come to call just-in-time curation. Just-in-time is a phrase that occupies a whole lot of the industry, but for the museum world, it's a fairly new concept. So one of our senior curators, Dag Spicer, and our vice president of exhibitions, Kirsten Tashev, came rushing into my cube one day and said, you know, there's this amazing thing. And they brought pictures of Jim's workbench. And they said, you know, this could be an absolutely phenomenal instant exhibition. And what's remarkable about that is that these are the 2 people. Dag was, I think, you know, in the pantheon of Silicon Valley organizations, the employee number that you have is really a kind of an honored thing, right? So Dag was employee number 1. And Kirsten, I think, was employee number 3. And for most of their careers, they've spent the last 10 years and have been at the helm of spending $20 million building the Revolution exhibition that we've just opened downstairs. So to think about an exhibition that we could suddenly open in 45 days at the museum was quite a very different thing. So we said to ourselves, well, what a cool thing that might be, you know, to just simply bring Jim's workbench and his whole office over to the museum and put it on display for everyone and kind of help the entire valley and people who would come to the museum understand, first of all, what an amazing intellect and talent Jim Williams was, and secondly, what analog technology and analog design really is all about. So we set about that and had the remarkable cooperation of Linear Technology in putting that together. And I have to say that, you know, I had the privilege of getting to know the CEO of Linear Technology, Lothar Meyer, and his wonderful wife about a year ago when we opened another temporary exhibit here in the lobby of the Computer History Museum. And I said to Kirsten Tashev, the VP of Exhibitions, you know, I think I'll just email Lothar and see what he thinks about this. And, you know, I expected to get 0 response back from Lothar because he's a very busy guy. I think you may know that this week, Bloomberg did an estimation based on certain metrics that they selected of the most profitable big public company in the United States. And their result was linear technology. Linear technology, not Apple, not Intel, not Ford, not any of the big companies you would think about, but linear technology, according to Bloomberg, is the most profitable company in the United States right now. So, being the executive director of a museum, emailing the CEO of the most profitable company in America, I didn't really expect to get much of a response from Lothar. But to my amazement and his everlasting credit, Lothar emailed me back in less than 2 hours. And he said, you know, absolutely, I think this would be a totally appropriate thing for us to do. And we were prepared to do it in any event. But I have to say that having the support and the generosity of linear technology, putting the exhibit together downstairs that I hope many of you have seen tonight, really enabled us to capitalize on this whole notion of just-in-time curation in a way that, as a museum, we've never actually been able to do. So I want to salute Lothar, John Hamburger, the Vice President of Marketing, and everyone at Linear who was responsible for this tonight. Now, if you've seen the bench in the lobby, you may wonder, how in the heck did they do that? I mean, that bench is pretty much pristine. I mean, it's as perfectly preserved as anything that a museum could possibly do, moving it directly from Jim's office to the museum. Well, the way that it happened, the key to that is shrink wrap. We had an entire team of our curator group with DAG and our curation team go over and just simply wrap it up in plastic. And they transported it to the museum and they brought it over here. I wish we could have done more. I mean, obviously, if you know Jim and you saw his office, you would have, his workbench area and his workspace, you would have known it was far richer and more complicated than we could possibly ever capture here at the museum. But I think, you know, with our ability to bring things over and keep it as intact as we could, I think we've done a pretty good job. And I can tell you that we opened this Tuesday night for a group of members and major donors to the museum, and we were looking back at the year that the museum has had, which has been, you know, a pretty remarkable year. We've had Bill Gates and Sergey Brin and the President of the United States and a number of other people who have come in since January, and they were all fascinated, absolutely fascinated with the fact that we had tried to bring this workbench over and really tried to portray the brilliance, the creativity, and the exceptional work style that Jim Williams embodies. And I think that this is going to be actually one of our most successful endeavors. Jim's workbench will be here for 6 months, so we're committed to keeping the space available here until March. We certainly hope that many engineers, young, old, engineers who have only heard of Jim, who may not even understand what analog technology and analog design is all about, will come and observe this both as a way of working and as a piece of art, and will help to understand what an absolutely remarkable person Jim was. So we feel that we're very honored and really very privileged to remember him, to honor his work, and to, I hope, inspire other young engineers, especially those who may be inclined to work in the analog space and may not fully understand it or even understand the potential and the future and the possibilities, who will come here and see this and will understand that this is a very, very important segment of computing and computer science, and maybe will be inspired to carry on Jim's work and Jim's legacy. One final thing I want to tell you just before I introduce the film and the panel tonight. We had 50 engineers from Hewlett-Packard in the museum yesterday. One of the things that we're discovering, actually, now that we've opened Revolution, is that we have young engineers by the hundreds coming into the museum because they're planning their away days, they're planning their retreats, they're trying to connect to the vast history of computing and the community that they're a part of. They come to the museum and they just simply want to spend a couple of hours in Revolution, and they want to try to connect to the things that computing has meant and means for the future. So we had these 50 HP engineers here yesterday, and we were talking about Revolution. I was explaining to them about the new installation of the Jim Williams Analog Life exhibit, and I asked them, how many of you have heard of Jim Williams and his work in analog design? And easily 2/3 of the hands went up. And I said, really, you know, you may want to start in the $20 million wing over there, but actually you may want to start in the, much more modest wing over here, the little exhibit that is a part of what Jim Williams was all about. And about 2/3 of them peeled off and immediately went over to see what an analog life is all about. And I think that really says something. It says a lot about what the museum hopes to be, how we hope to reach people who are in the industry, about the stories that we want to tell, and in particular, how we want to honor Jim Williams, his work, his incredible accomplishments, and his analog life. We're incredibly honored tonight to have here at the museum a group who knew Jim professionally, worked with him for many, many years, who've known him personally and who've taught with him at Stanford and in other places. We're going to honor all of that tonight. We're going to tell some funny stories. We're extremely honored to have many of Jim's family here and to remember him through this. But first, before I bring the panel up this evening, I want to introduce for you about 4 minutes, which is about half of a film that is showing downstairs in connection with an analog life, so that you'll see a little bit about the kind of storytelling and the way that we try to tell history here at the museum and the way that we try to bring things like Jim's accomplishment and his work to life in a way that everyone, the technical and the non-technical, can understand. So we're going to start with the film. We'll play a few minutes of that, and then I'll welcome the entire panel up, and we'll have this evening of reflection and celebration of the life of Jim Williams. Thank you.
The world is an analog place, whether it be temperature, pressure, flow rate, audio. Everything in the world is analog.
I call Jim a poet in circuitry.
Jim was, I think, a scientist. He was an inventor. He was artistic, and he was an engineer. And he had the rare ability to take all of those skills and integrate them together and make them easy to understand.
I can't tell you how many people use Jim as their sounding board for technical issues. And that's one of the great things that he would do. He'd always be available for you. No question was too stupid. And he would sit down, whether you were a senior guy or a junior guy right out of college, and he would slowly, methodically, and in a very helping way help you figure out what the circuits were about and what was going on.
When Jim Williams came in, he surprised me for his first interview. He actually showed up in Bermuda shorts. And I thought, wow, this guy's either really confident or weird. Came to my office and pulled up a chair as close as he could get to the front of my desk, looked me in the eye, and proceeded to interview me for an hour.
Early on, Bob Dobkin, who was his boss, encouraged Jim to write articles as he worked on application circuits. And Jim became well known because his application notes were very detailed and very thorough, but very easy for the reader to understand.
Math can describe, 3.29, it can give you all those decimal points, but it won't tell you the real understanding of what's going on, and that's how he communicated, very intuitively, he'd have little expressions that you'd pick up from reading him over the years.
I never really noticed Jim Williams' celebrity status at Linear Technology until I went to a customer visit with him. The customer completely ignored me and just went straight to Jim and said, "Oh wow, I finally get to meet you," and shook his hand. And there was a little bit of gushing involved, and of course I was kind of going, oh, what's going on here?
Jim had an app note years ago that was a page short, and the back page was blank. Bob Swanson saw the proof and said, "What's going on the back page?" Jim said, "Nothing, I finished." Bob said, "We're paying for that page, and it's not going to be blank." So he drew a cartoon, and it was a hit. Thereafter, all of his app notes had cartoons. Jim had a newborn son at the time in the early 90s, and Jim and his wife determined that Jim was the one who would take care of the baby at night. And Jim decided, what else do you do at night but hack circuits? Came up with the idea of baby bottles, denoting the complexity of the circuit. And a simple circuit would just get a couple baby bottles, and a complicated one would get a lot of baby bottles, signifying a feeding, a number of feedings. Customers still talk about that app note.
So my first impression of Jim Williams' desk was that I thought he was a mad scientist.
Jim would make his bench here at work as messy as possible to make it more difficult for other engineers to come by and grab equipment they would need for their measurements off of his bench.
He doesn't just pile up his circuit boards that he finishes. He assembles them, and he also places them that they kind of look like a mini city. There'll be like a bridge on top of two power supplies or something, and his board would sit on top in a slope.
He needed a part, it was there.
I would point investors to this maze of wires in Jim's office and say, that's analog design.
And the investors were really impressed. And they would walk away and think, boy, these guys are a bunch of gurus, and that must be some black magic. Just look at what it takes to be successful in analog.
So there's much more to that film, and I hope you'll see it all downstairs in the Analog Life exhibit. Please, now at this point, please join me in welcoming Bob Dobkin, Steve Pitkavich, Greg Kovacs, and Steve Young, our panelists for the evening, and we'll get started on the program. It's just fantastic to have all of you here tonight. And let me just take a minute to introduce everyone for those of you who don't know them. Bob Dobkin, for many of you, I think, who know Bob, really needs very little introduction. Bob is a founder of Linear Technology. He's the chief technical officer, and before 1999, he was responsible for all of the new product development at Linear. He has been a staple at Linear Technology for many, many years, one of the main people responsible for Linear's success. He holds over 100 patents at Linear. He is one of the legends in Linear ICs. He's authored over 50 articles and papers, and of course is the co-author with Jim of this amazing book that we'll be selling later tonight downstairs and that Bob will be signing. He attended the Massachusetts Institute of Technology, and we're really glad to have Bob with us tonight.
Thank you.
Bob, greetings. Steve Pitkavich. Steve Pitkavich is next to Bob. He is Vice President of Power Management Products for Linear. He served in that post since 2007. He's also had a long and distinguished career at Linear. He joined Linear in 1987 as a design engineer. He is a real expert and pioneer in analog design, and we're very pleased to have Steve with us tonight. He is a close friend and colleague of Jim Williams, and we're delighted to have you join us tonight too. Steve, thank you. Greg Kovacs is both an MD and an engineer. That's not an easy thing to achieve, ladies and gentlemen. Those of you who are either one of those know that. But he is an associate professor of electrical engineering at Stanford. He has a number of important degrees, including his MD from Stanford University. He was a teacher and has been a longtime professor and mentor of students at Stanford. and co-taught with Jim for many years at Stanford in connection with his work there. He's also been and continues to be the Director of Medical Device Technologies for the Astrobionics program at NASA Ames, and directs a wide variety of programs relating to wearable computers, something that obviously heavily depends on analog technology. Was a close associate of Jim for many years. Greg, we're delighted to have you here. Thank you. And Steve Young. Steve Young is here perhaps a little bit as the outsider, because Steve is not closely involved with Linear the way these other three individuals have been, and certainly has known Jim in a different capacity, but he is co-founder and developer of BAM Labs. He's been one of the key executives at Digio. Before that, he was the co-founder of Cepheid, where I think you were associated with Greg as well, right, Steve? So the two of them worked closely together at Cepheid, and they successfully went through an IPO 11 years ago. It's been a very successful company. Steve is a close friend of Jim's and a colleague, and understands his professional work and also his personal side. We're delighted to have you with us too, Steve. Thank you. So Bob, I'm going to ask you the very first question, because I think we want to begin at the beginning, really, which is where you came to know Jim. You gave him his first job at Linear. It was not his first job ever, but tell me a little bit about how you first encountered him and what attracted you to him.
I met him at National Semiconductor, and I had actually heard his name as being a very good designer, and at the time he was working at MIT, and he also did a lot of outside consulting. He did some work for ADL Corporation, and he came out to National, and I think the group of people he ran into there enticed him to come out and work at National Semiconductor, because he liked the environment, he liked the people he was working with, and we all kind of spoke the same language, analog IC electronics. And we got him out to work at National, and he did applications at National. And then when we left and started Linear, he wanted to join Linear almost from the onset, but right at the beginning we didn't have any products. We didn't need any applications for him. So it was about 2 years after we started that we hired Jim to work applications at Linear, and he was very happy doing it. He used to say, "I'm surprised they pay me for doing this."
So you knew him. I mean, it was someone that you really wanted inside the company as soon as you could.
We know everybody at Linear knew Jim, and we all wanted him inside the company right at the beginning.
Now, why was that?
Because he had a unique talent for coming up with interesting applications, and the reason they're interesting is because people want to read about them and they want to learn from them. So what better way is there for us to show off our best circuits than to have them used in some way that'll make other people read about it because they want to learn?
Was he immediately known for that? Was he not only for someone who did, amazing circuit design, but also documenting it and making it known to the wider engineering community?
As messy as his desk may look, Jim was very precise about how things worked. They all had to work very well, and he would document how it was so it could be duplicated. In fact, I saw him pull out this breadboard that was about 2/3 toward the bottom of the stack and get it running again because some customer called up, they wanted another measurement on it.
Now, that was really one of his trademarks, right? I mean, everyone, I think, has seen this workbench, this incredible workspace that Jim operated, but he had amazing recall for a particular piece of engineering that he'd worked on, didn't he?
It wasn't so much as of having to recall it, he just knew what it was. It's like language. You don't forget the language. And he understood all the pieces he put there, Some of them were made to be more sturdy because they had to be moved around, and some of them were just to take measurements on and write up. So they didn't need to be made very sturdy.
So maybe this is a point at which we should talk with you, especially Bob, about what is analog technology? Why is that so important? You know, someone came to the museum on Tuesday night when we were showing the workbench for the first time to a group, and someone said to me, look, I thought analog was the thing that you did before digital. And
That's all.
And now everything is digital, right? So why is analog so important?
Digital is a special case of analog. Digital deals with information. It's ones and zeros. It doesn't matter whether it's low-level voltage or high voltage or current or light pulses. It's the information that's transmitted is digital. Analog is all the rest. Analog is the value that you're transmitting. It's the speed that you're transmitting it. It's the, whether it's high voltage, low voltage, current, it's some measurable quantity. That's the analog world. And everything that we interface with is analog.
Dobby, the digital guys have this nice museum. Where's our museum? There's something we're doing wrong, I think.
It is all marketing, that's true. Now, let me point out, we have a whole gallery devoted just to analog technology. So we haven't completely overlooked it.
Well, analog is 20% of the market, so do we get 20% of the space here?
Yeah, you do. You've got 20% of the panel, I think. So that's pretty
more of it, yeah.
It should be more. Digital is either a 0 or a 1. It's either on or off. Analog is all the stuff in between. So it's just the two limit cases.
So before something turns it on and something turns it off, that's
what's happening.
So
as it gets from 0 to 1.
If an average, so let's assume that maybe a third of the audience here doesn't, even with that very erudite explanation of analog, doesn't fully understand it. If you pull an iPhone or an iPad out, or to be completely ecumenical, an Android phone out of your pocket, and you want to understand what is analog about that device, Steve, what is that?
The audio, the video, the battery, the radio. Gee, I mean the charger,
the antenna problem. I mean that's
the antenna, the touch screen, all that stuff is analog.
Okay.
If display was only black and white, that would be digital. We have color.
Nice. Okay, nice. That's good.
In between black and in between white are these other colors. That's analog.
That's excellent.
We are all analog. There's no digital people.
Humans
I don't know.
are.
Dobby's kind of digital.
Yeah.
We all know people.
Good. Well, this is going to be a rock and roll panel, I can see, because we have a good group here. So, Steve, you talk a little bit about how you encountered Jim at first, and how his work came to be known to you, and his influence within Linear.
Sure. Well, I started working at Linear in 1987. Linear was a small company. It was public, but I think I was design engineer number 12 or 13, or one of the first group of designers. And Jim, you couldn't help but notice Jim's bench. It was prominently displayed, and it was, the style was so much different than everybody else.
So already at that point, it was unique.
Who's this guy, Jim?
Yeah.
Now, Jim was actually, he wasn't an IC designer. He was an applications guy. He took, at first, just anybody's ICs, and when Linear started producing our own chips, he would, of course, use them and build applications around our products. So, all these early design engineers, we all competed to try to get Jim to use one of our chips in his app note. That was that felt really good when you saw your, as a designer, when you saw your IC in a Jim Williams app note. But I really got to know Jim. I see him working on a breadboard, and what is that, Jim? It's a switching regulator. And I didn't know what a switching regulator was, and it's, when I started working at analog, or at Linear, I worked at analog before I worked at Linear. Switching regulators are kind of of power management component that it's a huge business, not just for linear technology, but for many of the analog semiconductor companies throughout the world. But in those days, they were kind of new, and Jim was working on one of our early chips in an application. What's a switching regulator, Jim? Well, he was busy trying to ship his circuit to a customer, so he dug through his pile of stuff and pulled out this app note called Switching Regulators for Poets. I thought, I don't know what a switching regulator is, so I already like this title. I think maybe I can understand what these things are. And that's when I really became introduced to Jim's writing style and how he communicates complicated concepts in a very simple and understandable manner for non-experts. And that happened over and over and over again.
I want to pause for a minute, Steve and Bob, on this concept of an app note. Now, we saw in the film a little bit of a rendering of the paper that he wrote, and of course the famous cartoon that he would draw at the end. I want to hold on the cartoon for just a second, but could you explain to the audience a little bit what is an app note and why was it so important? I mean, the whole idea of a note seems something today in the nomenclature really small and well-defined, but actually what Jim did with his app notes was far more sophisticated and rigorous than the name would indicate, right? Could you talk a little bit about that?
Yeah. Once you're out of school, or even when you're in school, the circuits you're exposed to as you're learning electronics are relatively simple. And they may give you a little bit of the principles, but you don't see any of the techniques to do a sophisticated circuit that's bigger, that's more complicated, that has to do a lot of function. And there are people at companies that do it that have lots of experience, but if that's your product, you don't publish your circuits. So where do people get exposure to learn about how to do a circuit? One of the ways is they can look at existing circuits, and if they're explained, they can use the knowledge that's been explained to them to develop their own circuits. Well, we come out with ICs, and we want these integrated circuits to be used widely. So we try to think up lots of interesting circuits that do functions, develop the whole circuit around the IC, and publish it. And it gets us exposure for the IC, but also it's a teaching function to a lot of engineers that don't have a lot of analog background.
These were mini textbooks. I mean, we still use them today at Stanford. They're often a graduate student will come in, some smart guy who went to MIT and has a master's degree, working on his PhD or her PhD, and says, what's a switching regulator? And I throw the same app note at them. Switching regulators for poets. So they're mini textbooks, really.
So how often do you find, Greg, that you go back to these app notes that Jim wrote and use it for that purpose, for teaching purpose?
I would say every week, sometimes more, depending on what class we're teaching, but I give them to colleagues, and we hand out tons. And Jim actually brought a carload to us and filled a whole file cabinet. So I'm still giving out ones that Jim personally delivered, so on paper, instead of going, here's the link for it. And the students think that's really neat. What's this paper stuff? Like, it's pretty cool.
That's great.
Yeah.
So how did you first encounter Jim, Greg?
Well, it was a very long time ago, and he had always had this teaching thing in him, and we talked and, drank beer or something, and it ended up being, well, what you want to teach students.
What time frame was this?
A long time ago. So
long time ago. Okay. So this is pre-moon landing.
Longer ago than the bio that So the bio that's on the internet that's in here. Jim would have been the first to say, "Hey, Kovacs, this is wrong. You got promoted and you lost your hair. It's the wrong picture and the wrong bio." So Jim would have been on top of me for that. But it was a long, long time ago, and he came. He came and he I think he asked Dobby for permission. I'm sure that's what happened. Something like that. He shows up and he's got this car full of app notes and there's this big thump. And then I start to walk away. He goes, no, there's more. Come with me. And thump, 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 thump. And he came down to the class and we had probably three people who got that kind of reaction from our students: Bill Hewlett and Packard, and then Jim. And Hewlett and Packard were older. They would still show up, and the students would go, "Oh my God, oh my God." And the students knew who Jim was.
That's pretty heady company.
It's amazing. And so he came to the lab, which was usually at night. So the teaching labs are in the basement. Typically they put us, because we're geeky people, in the basement of buildings. So the basement, it's dark outside. The students are sweating over circuits. And Jim would go from bench to bench to bench. And he would always tell them why it was oscillating, why there was smoke coming out, why the smoke was blue in this case and gray in that case, and would sit there patiently, and we would round together. It was very much like medical rounds, and I want to come back to his medical interests. But he would do this tirelessly. And in years, and again, I won't let you pin me down on how long ago it was, because it's obvious I'm old, but anyway, it was so long ago. But only one time in all those years did he give up on a circuit that a student had built. And it was, I'll say, mostly digital, and it was so messed up. It was basically a ball of solder with a few leads sticking out, and you could barely tell what was in there, and he said, you really have to do this one over again.
Well, now,
one time.
So that covers a lot of the intellectual ground, right, related to Jim. But then there's the whole teaching aspect of him too, and I want to get everybody's reaction to Jim, because it's one thing to be able to design something and even to write it up, but it's quite a different thing to be able to impart that knowledge to your colleagues, to your team members within the company, to the industry at large. What was it that made him uniquely suited to be able to do that? Greg, maybe you could start, and I want to hear from others too.
Happy to. I mean, one of the things about Jim was he could communicate with anybody, whether they were a graduate student, a professor, or a freshman, and he could always get down to a level that was comfortable. Never talk down to anybody, always engaged. He was a great person for looking you in the eye, and he would always take the time to actually dig in. Instead of throwing out some little pearls of wisdom, he'd actually grab the thing and start probing around, actually hands-on. And so he was a natural teacher. And I think that's why he kept doing it, because the students told him over and over how much they appreciated him coming.
Did they gravitate toward him?
Absolutely.
Yeah.
Absolutely.
And he welcomed that.
He did. He did. And he would tell them, you need a certain component, that we don't have the right component. These people at Stanford buy the wrong stuff. They bought from Maxim and National. But anyway, so he would say, here's my address. Look behind the plant.
Yeah.
And he had a plant, and behind the plant were these tubes of chips and maybe a cookie or something.
So like a scavenger hunt.
Yeah. And so over the years, probably hundreds, maybe 1,000 students met the plant. And that was part of the Jim Williams experience.
Yeah, that's great.
And I don't know if you knew how many students came and went in the night on the porch there, but it was quite a Palo Alto experience.
Jim's ego was not about making you feel like you were small.
No.
If you were working on something you didn't understand it, he was not about making you feel like you didn't know anything.
Now, how did you first encounter him, Steve?
Oh, boy. So I was at Apple. No, it wasn't that. No.
If this involves drinking, that's okay.
Later. I was at Apple, and I was targeted to take Apple's 18-pound laptop and make a small one. So I was reading an app note on the 1070, and the back of the app note Jim had taken his business card and drew a head on it and arms and said, "Call me with your switching problems." And so at that time, Linear wasn't selling very many parts, maybe none at all, to Apple, right? So I call up, I go, "Hey, we're doing a new line of computers, and we're interested in some switching regulators." Well, of course, Dobby calls me right back. Jim gets the message from, he goes right to Dobby, and Dobby calls me back, and like a day later, I went to meet these guys, and they basically changed portable electronics. I mean, as far as computers go, we architected. Dobby had the world's smallest whiteboard. It's about this big in his office, and Dobby and Carl and Jim took turns wiping it off and redrawing what they were going to do. And we completely architected basically the power book in their office. The power system, which was the most novel part about it. And Jim actually got stuck with the toughest problem, which was doing the backlight. Back then, the backlights consumed about 50% of the power of the computer. And they were very inefficient, and they sucked, right? So Jim was stuck with the problem of taking these analog bulbs, these CCFL bulbs, and making them more efficient. He worked on it for 10 years, and at first he thought it was really exciting. We became really good friends during the process. But then later he said, "I'm still working on these stupid things, because I want to do something else." So I met him at Apple, and we worked together at Apple for a very long time, probably 5 or 6 years. It's probably 1989. And then every other company after Apple, Jim and Dobby have been a big part of whatever we did.
And you know, that thing about call me with your switching problems, the joke was if anyone called and said, I'm a man, I'd like to become a woman, he'd refer to me. Otherwise, he took them all. He took all the other ones.
Now, I want to actually. That's a really interesting exchange, and I just want to. I want to kind of poke around that. I want to poke into that a little bit because you used a phrase that I think is really interesting, which is he was stuck with the problem. And Greg, you said someone would call him. So I want to just get behind a little bit how he worked, right? Because it's one thing to someone to call him up, right, and say, I've got this problem, and I think that's what he was really well known for, right? Someone would just call him up. First of all, just to back up for a second, he didn't use email, right? Was that?
I would send him emails all the time, and they would respond. He would have his wife print them out, so he would print them out, and she would respond.
Yeah. So the way you connected with Jim Williams was you either walked in his office or you called him on the phone, right?
Yep. Always answered his phone.
He always answered his phone.
Yep.
And then you would say, I've got this problem. Right?
If it was a long problem, you'd bring a bunch of Coke and some Cheez-Its. And then you could
Coke and Cheez-Its. All right,
yeah,
okay, all
absolutely.
right. And then, so talk a little bit about how he would get behind that. I mean, someone would call him with a problem, and then he would just launch into it. Bob, can you talk a bit about that?
He would have infinite patience in explaining things to customers.
Okay.
More patience than I would. And he would go through all the details of what's going on, what's going wrong, and how to fix it. And
were there problems that weren't even going wrong? People would just call up and say, "Look, we have this design we're thinking of. We haven't even implemented it yet."
We would have Jim even inside. If we had some especially difficult problem, we'd go to Jim, and he'd come up with a circuit that was an answer for it. And then some of them, they were for testing different parts of an IC. We'd duplicate and send them out to the field so that the field would have these circuits to use. And I think on some of them, the performance that was required, I don't think anybody else in the company could have come up with the same answers as Jim did.
So you told me a couple of really fascinating stories about specific things that Jim came up with, like the thermos story. Can you just talk about that a bit?
This goes back to his very early days at MIT, and he was working on a project that was going to measure the energy of a cancer cell.
The energy of a cancer cell. Now, who brought this problem to you?
I don't know where the problem came from. I know that we talked extensively about how he was going to go measure the calories that were consumed or by one of the cells, and it required having an environment that was stable in temperature so you could measure the temperature change. And he had to make a temperature changer that was stable to 1/1,000,000th of a degree.
1/1,000,000th of a degree.
1/1,000,000th of a degree.
And he just attacked this with some relish, right?
He attacked it with some relish and probably redid it 4 or 5 times till it came out right.
And how did he do that? What was the technique he used?
The first technique was he tried to build a control circuit, and then he'd refine the control circuit. Then he'd find out it's not good enough, and he'd build a control circuit inside a control circuit.
Yeah.
And I think that's where he finally got to the right answer.
Tell me about the thermos part of that.
Well, to keep everything insulated from temperature changes on the outside, it was all built inside a thermos bottle.
Inside a thermos bottle.
Yes.
Okay. And that's just what he knew he needed to do in order to simulate the environment.
There's nobody that needs 1/1,000,000th of a degree stability.
Yeah.
So it's all new.
So there's no environment in which he could do that.
No, and there's no reference to start with.
Yeah. And how did it work out?
He got it there.
Huh.
He got it to 1/1,000,000th of a degree.
And
then we hired him to come out west.
Jim wasn't a classical engineer where he would sit down and design the whole system. He would just build it. He would take his first idea, he'd build it, and then he would, okay, if it's bad, he'd throw it away, but he would just start. And he learned every time he did a little work, he'd get some of it to work, he'd throw it away, add more. He just designed it. Most of the rest of the engineers you work with, they start with equations and paper. Jim just builds it. And he sees that's how he goes. And then later, he gets the math to work out whatever he did.
He would do it in his head. He would design it in his head, and he would build it. And when it was all done, he'd write down the circuit.
And then, I mean, that's really the important point, isn't it? From the standpoint of his contribution to the accumulated knowledge of analog circuit design, he would write it up, right?
He would write it up so other people could duplicate it.
Yeah.
He would write it up in sufficient detail that you could duplicate it.
And why did he feel so strongly about that? About documenting everything that he did? Because he wrote hundreds and hundreds of papers in this connection.
Jim never did anything by half. Okay, he wanted, if you're going to write it up and you're going to teach people how to use it, you do it right.
Steve?
He felt all these app notes, that was his primary work product. And that's just the way he operated. He'd build the circuits, and then writing was not really easy for him, but he would just go at it. You know, he'd do 24 hours, 48 hours, no sleep, just get it done.
Now, a lot of us, you know, we encounter something like that, especially writing, right? I have a good friend who's a writer, and he said, I hate writing, but I love having written. So, you know, but he had the discipline to sit down and really try to do that, right? To really document it.
So also, it's important, I think, to point out that he was really intuitive. And unlike a lot of engineers who just sort of bang their heads against a problem, he could sort of feel it. So it was much more like art than hard science. And students, one of the things I remember, he said this circuit's oscillating, you need to put 15 picofarads across these two leads, about the same as my finger, and went like this and put it on there, and the thing behaved. And the student was like, oh my God, you know, what is that? And so for a while, honest to God, this very impressed young undergraduate put his finger there and kept it there. So now what do I do? And Jim circled back and said, solder a capacitor across there. But it was intuitive circuit design, and we strive for that. That's our goal in teaching students, undergraduates at Stanford, is that they understand and the math follows. And sometimes the math is done in conjunction, but you have to have the understanding first of what each component does. And Jim could just see it. I mean, he could visualize the circuit. That's a real gift.
The remarkable thing about Jim, he was self-taught.
Yes.
You know,
Talk a little bit about that, about his.
He went to MIT to work, not to go to school. He ended up teaching circuits labs at MIT. Just self-taught, completely self-taught. He would look at circuits, he would look at test equipment, he would rip apart boxes, he would just look and figure out how things work. And that's the remarkable thing about Jim. With this self-taught, he didn't have a degree, no, you know, MSEE, anything like that. Yet, engineers all over the world would stand in line after he'd give a seminar to get their copy of his book autographed. And that's just, you just don't see that. That was what's so incredibly unique.
Jim taught
and
a
remarkable.
lab class at MIT, and people had to build circuits. And they would get in, they go, Mr. Williams, you know, the signal generator's not working. He goes, the manuals are over there. He would break the equipment so that the students in the class had to figure out how the equipment worked before they could figure out how their stuff worked. So he was kind of tough.
And you know, I got to say, many years later went to visit Roberge, Professor Roberge at MIT, who had worked with Jim in his labs. And I mentioned Jim to him, and he just got this wistful look, and he stared off in the distance for a while and just gushed about Jim. And I knew that in that period of staring off in the distance, he was thinking of how Jim pranked him. Because you know, he must have got pranked every quarter.
Yeah.
And I don't know if anyone's going to talk about that, but boy, he's a master.
For people who work with students, sometimes you find that students really, they want to know the right answer. They want to know that kind of step by step thing so they can replicate it. But what you're saying really is that this intuitive quality about him just was kind of an intuitive problem-solving thing. And that's a difficult skill to transfer to students who often are very step-by-step. So talk a little bit about how he handled that.
Well, when you come to analog circuits, not only is the input and what you get out important, it's the path you take to get there.
Yes.
With digital, You put numbers in, you get the number out. The path isn't so important.
We're really trashing digital tonight, I think.
Yeah. It's warranted.
That's okay. No, I'm sorry. Go ahead. Go ahead and continue.
So, in getting the analog circuits running, you have to kind of see where the currents flow and how they flow in the circuit. And when you draw down the schematic, it has to be so that you can follow the signal paths through the paper diagram in your head and see how it's going. And that's part of the intuition of putting everything together in your head so you can understand it. You get a really experienced analog engineer, you come up with a big complicated circuit with lots of stuff in it, he can pick it up and look at it, and 30 seconds later he knows what it does. You don't get that by writing the equations. You get it because you've got some intuition about what all the components do.
And you saw him impart that to young engineers.
That's the way he worked. So they would see him doing it, and they would start to understand, but it takes a long time for somebody to get there.
And he had that patience to be able to take that time to be able to do that.
At least get him started.
Yeah. So I want to talk just for a minute about the playful side of Jim, right? Because the prankster quality of him was an important one. And but before you're nodding heavily,
I was the recipient of most of them.
I want to get to you. I want to talk to you. I want to get to you for just a minute, Steve. But Steve, the other Steve, you talked about in the film the baby bottle index, right, to the complexity of a circuit. So can you just talk a little bit about how that came to be? Because it's such a human kind of wonderful way of marking both his milestones and the way he thought about problem solving.
Well, that particular story, we worked with a graphic artist who, and Jim, like people have said here, he talked to anybody. He had no ego. He was friendly and straightforward with everybody. And he was telling our graphic artist about what he was doing with the baby on top of the scope in the baby basket. And they together hit on this idea of these baby bottles, and then
he's staying up late.
Because he's staying up.
He's got a baby,
and he's telling, "Gee, this took 2 nights." And that's 2 baby bottles.
That's 2 feedings,
that's 2
right?
feedings, right?
Yeah.
And then they extended it. They did, well, what if it took, you finished it during a feeding? Will it be a half of a bottle or a quarter? And so some of those circuits have 3 1/4 or 3 1/2, or he would just go with it. He knew he had a good thing, and he just had this ability to say, "We're going to go with this. This is going to get play."
And did people who read his app notes see the baby? But did they start to get what that meant? Really?
Sure. Yeah. I think he said something in the introduction of the app note.
Yeah.
About how he scored these circuits.
And the baby bottle scoring system.
Yeah.
All right. So Steve Young. Go for it. I want to hear some of the...
I can tell you about 10, but I'll only do a couple.
All right, okay.
So the first one I had from Jim and I know only each other for a couple of years, and I was like a really big customer of Linear, right? So I go home for Thanksgiving. My parents live back east, and I come back, and I try to open my front door, and it's like springy. Okay, so finally I get in the house. Jim had bought weather balloons and blew them up inside my house. Like 12
weather balloons.
Weather balloons,
These
right?
are not small.
No, they were like 12 feet in diameter. They were in all the different rooms. And he thought this was hysterical, right? It was pretty funny. Except when you try to get them out, they're full of talcum powder. The entire interior of my house was powdered, right? So that was the first one he did. Another one he did, he didn't do it to me, he actually did it to another friend of ours who's out here, Lenny. He took one of these catalogs that Maxim had put out, and it had a card to return for information, right? So Jim took the card, taped it to a brick, and sent it to Maxim. Gets a call back from Lenny, very funny Jim, right? Everybody in Maxim knew that he did it. He was a character.
Exactly.
Page.
Yeah, it was a business reply.
So there's a famous, really famous story that's in the film about the digital clock, right? The prank involving the digital clock?
It was analog.
I'm sorry, the analog clock. The
there's actually
analog
two clocks.
clock. Yeah.
There's
yeah.
two clocks.
All right, so go ahead.
The digital clock Jim didn't do much with, but he knew about it.
And he would just mess with this, right? This was.
And he knew about the digital clock, and because he knew we were messing with the digital clock, he decided he'd mess with our clock, which was the analog clock. And the clock was on the wall, and it starts running slow. We don't think anything of it. It's broken. It's replaced.
It's missing a minute or
Get
two.
another one.
Yeah.
Then it starts running fast. Wait a minute. 2 clocks changing in 3 days? No, that's not right. So we open it up, and the crystals change. The thing that sets the timing, it's different. So we get a good crystal, put it back up. Come back in, and it's running backwards.
It's talk about this. It's running. How do you know it's running backwards? I mean,
we're watching it. The minute hand's going backwards. Okay, well, we said, okay, he switched the wires in it. So we open it up and switch the wires. There aren't a lot of wires in it. It continues to run backwards. Doesn't matter which way we hook it up inside.
Okay.
It continues to run backwards.
Yeah.
I call up the manufacturer of the clock. I get to the guy who designed the clock at Timex, and he says it can't run backwards. I'd like to see that. Well, we looked into it, and we actually found out what they did. What he did was he had filed on some of the magnetic pieces inside, and that made it run backwards.
Yeah. Now there somewhere in here there's a hand grenade.
Oh, that's the
right.
It went back and forth for another 3 or 4 weeks with us putting backwards numbers on it, and then it running different speeds backwards, and us setting up cameras that tried to take a picture of him in the middle of the night, and him putting tape over the lens, and putting sets of flash bulbs in the clock, so when it came off the wall, all the flash bulbs would go off in his face.
And he wrote a note, right? He said.
Right. And the end was we take it off the wall, the flash bulbs go off, a fake hand grenade falls out with a note.
And the note says, "This is as close as you're going to get to getting a picture of me," or something like that, right? Yeah. Now, so especially you and Steve Pitkavich, I want to talk a little bit about his influence on young engineers that he worked with every day, and his ability to sit down with them, talk to them, train them, talk about his own knowledge, his intuition. Can you talk a little bit about that? Because you must have encountered hundreds of engineers over the course of his career and had a real impact on them.
He himself was a great engineer, probably one of the world's best. He would see young guys come in who might be really good circuit designers, really good at have the tools and the smarts. He would teach them, the best ones, to be great engineers, which is different than being a great circuit designer. Because Jim always had his eye on, you got to ship this thing. The customer has to want to buy it, preferably in mass quantity, and they all have to work, and it has to please the customer. So Jim had that last bit that got a circuit into a product, and just because of his intuitive way of working. And the good engineers, they'd watch him go and say, "Oh, I want to do it like that." And he's influenced a lot of writing styles and a lot of design or data sheets. We always talk about the theory of minimum phone calls. You want to write your data sheet, and the designers at Linear write their own data sheets so that as few people as possible call you up. Well, how do you do that? Well, you write clearly and concisely, and you tell the customer exactly what your product does and how to apply it. And Jim was always beating on the guys. You need to make sure people understand your product.
So, Greg, you must have seen him interact with so many young engineering minds, right?
Yes, and we had discussed that this was going on during the era of outsourcing, and that you're not going to be able to outsource someone like Jim. You can't have, this is the linear circuit technology outsourcing circuit helpline in Bombay. Can I help you? That's not going to happen. It has got to be right there, and he would show up. And a lot of the time, he'd be pulling the parts off. So, it was really a hands-on thing. And he did influence generations of students. In fact, there's at least one PhD from Stanford that was directly because of one of his app notes. And it was amazing that he's had that much influence over the years, and will continue to.
Did he have a sense at the time that he was having this kind of influence on young engineers?
He did, and this particular student who did his PhD on this was a device for monitoring the heart. And Jim came to the oral defense and sat there, with this very non-egotistical way that he always had, and you could see that certain smile on his face because he knew this was something. That little app note, that little side thing in the app note generated, and the student was just so proud that Jim came. It was a big thing, and that was one of the best moments of feedback to him, that he saw this big fella. Actually the student was 6'4", 350 pounds, so impressive in that sense, but just, he said, that's Jim, that's Jim Williams.
That's fantastic.
It was really great. And then legions of undergraduates still carry around his app notes that had his little notes written in them and things like that.
So we're going to take some questions from all of you. If you've got your Q&A cards, we've been collecting them for a while, and I just want to call those up to the stage and start taking those in a couple of minutes. But Steve Young, I want to ask you about Jim personally, just as a friend, as a colleague. There were, many people have talked very eloquently about those qualities about him, and I just wonder if you could do that.
Jim was the most generous person I've ever met.
What made him so generous?
Yeah, he would say things like, he was also very prophetic. He would say, you can make more money, you can't make more time, right? He was one of those guys that would give you his time. It was the most important thing that he had. And he would, if you had a problem, no matter what it was, your car, your friend, your girlfriend, whatever, he would come and talk to you about it. I mean, he made time to talk to you about anything, right? And he was a really generous guy. I mean, with his resources, I think he was a very smart guy. So it was very fun, We spent a lot of time together, and he really always wanted to have a good time. I mean, that was really important to him to enjoy himself, right?
Yeah.
And he would really enjoy himself at my blood, he took out of me, but we had a really good time. He he was a really generous guy.
Did you do the flea markets?
I do the flea markets with him all the time.
With him, so tell a couple of the flea market stories, because that's a really uniquely Silicon Valley thing.
In Silicon
right?
Valley, we have flea markets for nerds, and it starts really early in the morning, and these people come with junk. Who knows where they get it, And they show up, and they have their little stalls, their little store for the day. They get there at like 4 o'clock in the morning, and Jim would get there at like 4:30 because all the good stuff was still there, right? And he would go row by row, and he would find stuff he wanted. He'd buy it, and he'd put it in his car. And so I would get there like 7. I was a normal person, so. And Jim already had all the good stuff, right?
Right.
Yeah.
And he was, we called ourselves junk diodes. The stuff would come in and never go out.
That's
so
right.
Our houses filled up, and they're all filled.
Yeah.
Now, someone told me the story about the oscilloscope.
Oh, he got an oscilloscope.
Right. So talk a little bit about this oscilloscope that he discovered at a flea market.
He went to the flea market. He found
Thank you.
What he found was an infrared detector.
Yeah.
Oh, yeah.
That was classified, and it ended up in the flea market. And he bought it because he had actually worked with the company that developed these detectors. And he called up the company and said, I've got one of your detectors here. Are you interested in it? And they said yes.
Slightly.
They said, that was one of our better ones, too. So, you want to sell it? And he said, no, but I'll trade it to you for a scope.
I'm really interested, in the relationship between the way his mind worked and his art, because he really had an artistic bent to him, right? I mean, you can see one of the wonderful things about that workbench is the kind of three-dimensional quality in which his mind worked. And that's part engineering and part design, and it's also really part artistic and creative. You want to talk about that for a minute? I think that's really fascinating.
He's a sculptor. I mean, you see his house, there's sculptures all over the place.
Yeah, he's made a tremendous amount of sculpture, right?
He spent a long time making those sculptures, and he would agonize over what part he's going to put in there, you know. And he made them out of Michael's toys. You know, there'd be things like there'd be a bird in there, like this thermometer has got a bird in it, right? So he was a sculptor. He really enjoyed making 3D things.
Yeah.
In fact, there's a lecture that I give undergraduates on the electronic art of Jim Williams.
Really?
Yeah, and they love it. And one student, you know, this is a true story, was struggling in electrical engineering. He really wanted to express himself as an artist, and he saw that, and he elected to do a double major, and actually graduated with a bachelor's degree in a double major between art and electrical engineering, and he went on to do electronic sculpture.
Now, how do you go about that? I mean, what's the concept of a class built on the electrical art of Jim Williams?
Well, so what I did, Jim took me around and showed me the art that he'd done, and I noticed there was a picture of one of the book covers that had one of the beautiful examples.
Yes.
And we took pictures.
Yeah.
And he told me the stories, and then I would just march through these pictures and tell the stories, and some of the students would call them up and go over to the house and see them.
Yeah.
And they got really amazed because these things, you can't convey that they're three-dimensional very well with a photo.
No,
and
you
they're
can't.
they're amazing. And anyway, it really is art.
Did he think in three-dimensional terms as an engineer? Was that your experience, Steve?
Well, you know, circuits are they can be three-dimensional, more two-dimensional. But when he was building, he would use that third dimension, that height dimension. He wouldn't just build a flat board. He would take advantage of everything that was given to him, and if it meant a skyscraper kind of circuit board, that's what he did. He got the job done. So he's very pragmatic in that way. But I have a story about the art that moves, that intersects with the junk, the swap meets. And he found these 7-segment displays that were very large, and he thought they were very beautiful. And he bought them all at one of the foothill flea markets. And what am I going to build with these? They're just too cool. I have to have this. And so he decided on a barometer, barometer pressure gauge, right? Okay. To look at atmospheric pressure. And he built it, and it was in his office on his wall. And he was, how should I design the circuit? He could easily design it many different ways, but he thought, what's the most beautiful way to design the circuit, and what kind of components should I use for various parts of the overall circuit? And he wrestled with that a long time before coming up with what he finally built. And every day when he got into work, he would turn it on because it plugged into the wall, and he was very mindful of, you don't want the thing to catch on fire. He had it fused and lots of protection in case something went wrong. And he would put his keys on the switch, so that he would always remember when it was time to go. He actually couldn't leave before getting his keys, and then he would have to turn off the switch because they were behind the switch. But that's quite an artistic piece that was right behind his desk.
So there are that's a great story, and we've got a lot of questions, great questions here. I don't know if we can get to them all, but some are more philosophical and some are more specific, and I want to start with one that's very specific, which is we've talked about these app notes and his kind of prodigious way of documenting the work that he was doing, but he did it with no computer, right? Did he do it with, he needed no processor, word processor, no computer of any kind?
No computer.
No computer of any kind. So what did he do? How did he do that?
Yellow pads. Yellow pads.
Yellow legal pad.
Yellow legal pad.
And a mechanical pencil.
And a particular kind of mechanical pencil, right?
Pentel something
He had a
pencil.
preference.
Yeah, he bought them in bulk. He must have had 50 or 100 of them.
And he would tape. Someone told me he taped the pages together, right? And they would just kind of cascade down.
He'd have
the wall.
errata and the things wrong, the things that he'd have to fix, and he'd have 6 feet of legal yellow notepad.
So you were his co-author. Is that the way you wrote the book?
He did. Well, he wrote the book. He wrote the app notes. I didn't write the app notes.
Okay.
Then when we're taking the book and putting it together out of the app notes, everything had to be proofed.
I see.
And that's what one of the things that I did. I kind of didn't feel right putting my name on it, but Jim wanted my name on it as well. He didn't want to take all the blame.
I like that. That's the ultimate analog way of writing a book, isn't it? All on yellow legal paper, and that's fantastic. Let me talk about a couple of the more philosophical questions here, which is, and this is one we talked about in the preparation for this panel. So there's a whole new generation of engineers coming up, and I think, Greg, you put it in a very articulate way, which you said they're voting with their feet. They're not necessarily pursuing analog engineering as a career, and it may be in as many numbers. So if other people wanted to emulate the work that Jim did and follow along and improve upon it, what advice do you think Jim Williams would give to a young engineer thinking about this as a career? Bob, you want to start with that?
I think that it starts with wanting to take things apart and then learning how to put them back together again. You don't learn to work like Jim did, or even most of the very good analog engineers, out of a book. You end up by doing it or studying what other people did. So the app notes that he's done is a good start, because you can see how other people are thinking about doing a solution. And once you understand that, you can start thinking about doing your own. But I think more than anything, you have to develop the sense of understanding a circuit without writing equations, and be able to look at circuits and understand what they're doing quickly.
Steve, what would you say?
Well, it starts with curiosity of wondering how all this electronic stuff in the world around us, how does it work? And there are people who are interested, and there are people who just are happy just to use it and don't care how it does what it does. But for young engineers who have that curiosity, how does this stuff work?
So really, engineers with a curious mind.
Yes, analog's a great place to be. It's a great career path.
Yeah, Greg.
Well, I think a lot of us grew up in the era of building things, and that kind of went away for a while. The Heath kits went away, and back when I was starting with my dad, we had primitive stuff. You're stoking the coals for the steam-powered transistors. All kinds of things were early tech, brass. But now there's a maker community again, and the students embrace that. So we tell them to build things. And every day that I teach, I think about teaching the way Jim did, which is to tell them to put away the equations, don't take notes, look at the circuit diagram and understand what the components do, and then how they work together. So it's sort of a theater sports thing, the way I teach analog circuit design, and it at least gets them to stop the rote learning, because that's not how you learn it. You learn it by doing it. And then we actually have labs where they have to build things and figure them out, and they don't work the first time. And I encourage the students to go to the swap meet and buy stuff and fix it or take it apart. And I think that was well said by Dobby. So
yeah. Steve?
I think you have to have a problem. Like Jim, he started fixing TVs when he was like 10 years old. He got a job in a shop. The guy would pay him cash under the table. Actually, he didn't pay him cash. He'd leave the money on the floor. Jim was too young to be working, right? So he was fixing TVs. So he had a problem. He had to learn how the circuits work so he could fix the TVs. So he had a motivation, right? So I think now it's the same thing. You have to have a problem that you have to fix if you're an engineer. I mean, that's kind of...
I think Steve's right, but when you start fixing TVs, the TV comes with what the circuit is, but they don't really explain why they did it and how it works. You have to sit there and figure out what it's supposed to do and compare it to the broken one and get it running again.
That's what Jim told me when he was a young kid. He started fixing TVs. I said, how'd you get into this? And the neighbor had an oscilloscope, but he started fixing TVs. And he went the whole story, 20-minute story about he wasn't supposed to get paid and it was illegal, but he still fixed the TVs. That's how he got started.
I heard he got paid in lollipops. He was pretty young.
It was cash.
Okay,
cash.
He just wanted to use that oscilloscope.
That's exactly what it is.
That's what the driving force was. He just loved that oscilloscope and would look for anything to hook it to.
So one final question, which has also come from the audience, which is if Jim were to be sitting out there in the audience tonight thinking about this event for him, what do you think he would say? I'm going to start with you, Steve, and work
Jim
this
would be
way
thinking
down.
about circuits right now. He thought about circuits all the time, right? I have a quick story. When he first met CU and he went on their first date, I go, how did it go? He goes, I didn't think about circuits all night. Wow. So he thought about circuits all the time. So he was obsessed. That was his thing.
There was a famous app note he wrote from a beach somewhere, right? Someone told me this story about he was away on a vacation, and someone asked him what he did, and he said, I wrote this app note, right? Greg?
I think he'd be also thinking that it's good that we're discussing how to become an analog engineer and what analog circuits are, because we always sat around worrying about students maybe someday not being interested. Thankfully, that didn't happen. And, we're trying to carry that legacy on. I think he'd be happy that there are other people like him worrying about education in analog.
Steve?
Well, I think if Jim were here, he'd be wondering what all the fuss is about.
Yeah.
But let's get back to work.
What are we eating? What's for dinner?
The spherical hamburger,
Bob?
I was going to say the same thing as Steve, because that would be Jim.
That's great. Well, I'm sort of reminded of that great phrase that Hollywood gave us a few years ago, which is a beautiful mind. Someone who was fantastic as an engineer, a friend, a mentor, a colleague, a pioneer, someone who was incredibly creative and meant so much to so many things that we take for granted and use every day, and yet was so perhaps unknown and unsung. And for us as an institution, that's really, I think, one of the things that we try to bring to the forefront and try to remember and bring into the public mind, that people like this, engineers like Jim Williams and Jim specifically, do amazing and heroic things. They're things that have brought so much progress to all of us and made so many things we take for granted just a part of everyday life. And they need to be remembered, but not only because of what they've done, but because of the inspiration that they can bring to future engineers. So I'm really delighted that you could be with us tonight, that we could have this evening, that we could remember Jim Williams in an analog life, that we could launch this exhibit downstairs and have it be here for a few months to maybe inspire and inform others. So thank you. Please join me in thanking all of our panelists.
And it's nice that the Computer Museum is recognizing analog.
Thank you, Bob. Thank you. Thank you. Great plug. I want to personally once more thank Lothar Meyer and Linear for everything they've done to support this, and thank all of you for coming tonight. Thank you very much. Good night.